All right, well, did you already try to work these? That'd be great if you did. So I'm going to go ahead and go through this pretty quickly. Hopefully get this done within 5 minutes. All right, so you're determining if it's growth or decay and then solving. So annual annual sales for a fast food restaurant were $650,000 in annual. So every year, $650,000, and are increasing at a rate of 4% per year. Use the exponential function to find the annual sales after 7 years. So it's increasing. So this is going to be growth. So for your growth rate, remember, you're going to use the 1 plus because you're growing that rate's 4% every year. So we have our initial, so 650,000 at a growth rate of 1 and 4%. So a lot of times I do this. 100% plus 4% is 104%. So my decimal really is 1.04 after 7 years. So sometimes I go straight into this equation, 1.04 in that equation. I'm fine with that. If you don't want to write this one and go straight to here, that's good. I'd actually prefer that. Saves you just a little bit of time. So again, do your exponent first. So all right, on, clear, 1.04. Exponent, the caret, 7. That's going to be 1.3159 if you want. Again, I like to write it down just so then if something's wrong, I can go back and kind of see what my numbers were. Times 650,000. 3, check it, make sure that's 650,000. Now it's growing. So if your number's less than 650,000, guys, something's wrong. 855,355. I just like to write it down and then decide. So it doesn't tell me what to round to. So this is going to be, you could leave it like that. So approximately 855,355 or 56. But you're talking about money. So you can leave it like that if you want. If you want to round to the nearest thousands, 850,000, that's fine since this is an exact. So you can even say, okay, 850,000, yep. So anywhere like that. But if your number is lower than 650,000, something's not right. All right, so let's look at the next one. Now don't just assume it's a decay. A lot of people do that. They're like, oh, growth, this has to be decay. Population of fish start at 8,000. Oh, and decreases, so it is a decrease. It is a decay, 6% per year. And we want to know after 10 years. So the population started at 8,000. Then it decreases 6%. So remember, you're taking 100% minus 6%. That's 94%. So as a decimal, that's going to be 0.94. Don't put 0.06 here. If you do, you're saying you're losing 94% of the fish every year, not 6. So make sure you take 100 minus the 6%. Okay, now again, this is less than 1, so I know it's a decrease, and then 10 years. All right, now use your exponent. This is not saying 0.94 times 10. So use your calculator. 10 equals 0.5386 or whatever, however you want to do it. 8,000. I'm leaving it in my calculator to be more exact. So about 4,300. So you can do 4,309 fish. You can do 4,300. About 4,000 fish. So it's almost gone down in half. Look at that. 6% per year for 10 years. It's almost decreased by half by the time those 10 years are up. Okay, so we're talking about fish. So that's how many fish are left in wherever this is. A pond, a lake, whatever. Okay, so now 7, 8, and 9, you are just determining whether the function represents exponential growth or decay. Identify the percent rate of change. The only thing you're looking at, determining the difference between the growth and the rate. The growth in your rate is right here. And remember, this should look familiar, and it just hit me to tell you guys this. This should look familiar to our exponential function. Remember how it's ab to the x power? This is your b. This is your b. Your x power now is just t for time. So these formulas are the exact same. It's just depending on what we're talking about. Since it's percent, we did the 1 in front, 100% plus or 100% minus. So when you look here, the only thing you're considering is right here in the parentheses. Is this over 100%? Yes. So this is going to be a growth. Now remember that got changed to a decimal. So this is going to be 7%. Now what you can do if you want, you can make that 107%. Well, what's above 107%? So the growth is at 7%. This one, this is a decay because it's less than 100, but be very, very careful. It's not 98% decay. It's only 2%. Okay? Think of this as 100 minus 98%. Well, that's 2% decay. This is where most people will make a mistake. They'll just put 98, so be very careful there. This one, a growth, and at what percent? 2%. I like the growths because they're easy. You don't have to really do any subtraction or calculation. The decays you have to worry about. Okay, well, that was 6 minutes, so that wasn't too bad. All right, thank you.